So this video, I'm going to explain the research process in detail with examples. So research process means it is a systematic sequence of different steps followed to conduct scientific research. This research process helps researchers to solve problems and generate new knowledge in an organized manner. The first step is identifying the research problem. The first step is to identify what is the research problem. For example, a researcher may study how can automation improve manufacturing productivity. After identifying the problem, the researcher conducts a literature review to study previous research papers and journals. The next step is formulating research questions and objectives. Example, does robotic automation reduce production time? And the researcher develops a hypothesis. Example, automation increases production efficiency. The researcher selects a research design and collects data through surveys, experiments, or observations. For example, production data from industries may be collected. After data collection, data analysis is performed using statistical tools. Finally, the results are interpreted and conclusions are drawn. The findings are then presented in the form of a research report. Thus, the research process ensures systematic and reliable scientific investigation. Once again, explain research process in detail. Research process is a systematic sequence of different steps followed to conduct a scientific research. This research process helps researchers to solve problem. First of all, the researcher need to identify what is the problem and generate new knowledge in an organized manner. If there is a proper process, then this will help the researchers to solve problem and generate new knowledge in an organized manner. The first step in research is to identify the research problem. For example, a researcher may study how can automation improve manufacturing productivity. After identifying the problem, the researcher conducts a literature review to study previous research papers and journals. The next step is formulating research questions and objectives. For example, does robotic automation reduce production time? Then the researcher develops a hypothesis. For example, automation increases production efficiency. Then the researcher selects a research design and then collects data through surveys, experiments, or observations. For example, production data from industries may be collected. After data collection, data analysis is performed using different statistical tools, for example, R software. Finally, results are interpreted and conclusions are drawn. Then the findings are then presented in the form of a research report and publish the result in a paper. Thus, the research process ensures systematic and reliable scientific investigation. What do you mean by research questions and their importance? Research questions are some specific questions that a research study aims to answer. They guide the direction and objectives of the research. A good research question should be clear, focused, and measurable. For example, how does online learning affect student performance? What is the effect of temperature on metal expansion? So research questions are important because they help researchers identify the scope of the study and select suitable research methods. They prevent unnecessary data collection and improve the research efficiency. Research questions also help in developing hypotheses and interpreting results. Therefore, research questions are considered as the foundation of scientific research. What is research design? Research design means this is the overall plan or framework to conduct research. It helps it helps organize data collection, sampling, and analysis methods. There are different types of research designs, such as experimental design, survey design, case study design, descriptive design. For example, in survey design, a researcher may collect opinions from students using questionnaires. In experimental design, a researcher may study the effect of machine speed on production quality. A proper research design improves accuracy, validity, and reliability. Thus, research design is essential for successful and scientific research. So research design means the overall plan or the overall framework used to conduct research, how to collect data, how to do sampling, what are the methods used. There are different types of research design, such as experimental design, survey design, then case study design, descriptive design, etc. What is the difference between quantitative and what is the difference between quantitative and a qualitative approach? Quantitative quantitative research means that is dealing with numerical data and statistical analysis. This mainly focuses on measurements and objective results. For example, measuring student marks using statistical analysis, that is dealing with the numerical data, or studying the production output using numerical data. Qualitative research or qualitative approach means focuses on experiences, opinions, then behaviors, etc. So this qualitative approach is using interviews, observations, discussions, etc. For example, interviewing students about online learning experiences. This is an example of qualitative approach. Or observing the behavior of workers in factories. So quantitative research provides measurable results because that is dealing with the numbers, while qualitative research provides detailed understanding and interpretation. So both approaches are important for comprehensive research studies. Then, building and validating theoretical models. Theoretical models means theoretical models or theoretical models are conceptual or mathematical representations to explain systems and process. So this theoretical models are conceptual, or it is the mathematical representation of a particular system or a process. So this mathematical representation is used to explain that system or process. That is what is called a theoretical model. For example, in engineering, a mathematical model is used to predict the machine performance. In economics, we can use theoretical models to predict the behavior of the market. So these are the different types of theoretical models. So theoretical model means it is used to, these are conceptual or mathematical representations of the system or the process, of the real system or the process. With the help of this mathematical model, we can predict the behavior. For example, the example I have mentioned, in engineering, using mathematical model, because this mathematical model is representing the machine. So I can predict the performance of the machine with the help of this mathematical model. Again, the market behavior in economics, the market behavior we can predict with the help of this theoretical model. The first step is to identify variables and relationships. For example, researchers develop equations or conceptual frameworks. After model development, validation is performed using experimental data. For example, a simulation model for robotic movement can be validated by comparing simulation results with real robot performance. Validation models improve prediction accuracy and scientific understanding. So in theoretical model development, we have to identify what are the variables involved in this and what are the relations between these variables. Then researcher will develop equations or conceptual frameworks. After once developed the model, the next will be the validation with the help of experimental data. For example, we have a simulation model for robotic movement. This can be validated by comparing we have the simulation results. We will compare this simulation results with the real robot performance. So a comparison between the simulation results with the real robot performance. Validation models improve prediction accuracy and scientific understanding. Exploratory versus confirmatory research. Exploratory research means, again, from the name itself, exploratory means this is to explore new ideas or new problems with limited information is available. So exploratory research means the information available is very limited. So we have to explore new ideas, new problems. That is what is called exploratory research. For example, studying a new technology, studying a newly introduced technology, or exploring customer opinions about a new product. These are the examples of exploratory research. Confirmatory research means test existing hypotheses or theories using structured methods. Confirmatory means the main aim is to confirm whether the hypothesis or theory is correct or not. That is called a confirmatory research. For example, testing whether automation improves productivity, verifying the effectiveness of a medicine. Then exploratory research is flexible. The main advantage of exploratory research is that is flexible because the information is limited. So it is like an open-ended. But the confirmatory research is structured and statistical. Both methods are important for knowledge development and scientific analysis. Then experimental versus theoretical research. Experimental research involves practical experiments to study relationship. So the main thing is that studying the relationship between variables, right? So in experimental research, this involves some practical experiments to study the relationships between variables. For example, testing the strength of materials in a laboratory or measuring the machine performance under different temperatures. So we have to study what are the relationships between variables. So the researchers manipulate these independent variables and observe their defects on dependent variables. So we have independent variables and we have dependent variables. So researcher will manipulate the independent variables and observe what are the effects by changing this independent variable, how this will affect the dependent variable. Then theoretical research means that is basically dealing with concepts, theories, and mathematical analysis. For example, developing mathematical equations for fluid flow or creating simulation models for robotics. Experimental research means will get practical evidence. while theoretical research provides only conceptual understanding. So both are important for scientific and engineering advancements. What is the importance of reasoning in research with examples? Reasoning means that is dealing with the logical thinking used in scientific investigation. So this reasoning will help the researchers to analyze the information and draw conclusions from the result. There are two main types of reasoning. One is deductive reasoning and inductive reasoning. Deductive reasoning starts from general principles and moves towards specific conclusions. For example, all metals expand when heated. All metals expanded when heated. So this is a general principle. All metals expand when heated. So iron is a metal. So the conclusion is iron will expand when heated. This is a simple example. So this is what is called a deductive reasoning. Deductive reasoning starts from general principles and moves toward specific conclusions. So example is all metals expand when heated. Iron is a metal. So the conclusion will be iron expands when heated. Inductive reasoning. Inductive reasoning starts from observations and develops general conclusions. For example, copper expands when heated. Aluminum expands when heated. Iron expands when heated. So I can say all metals expand when heated. So inductive reasoning starts from observations and develops general conclusions based on that observations. So reasoning will be classified into two: deductive reasoning and inductive reasoning. So reasoning will improve the critical thinking, problem solving, scientific understanding. So proper reasoning will increases the research validity and reliability. So research process is a systematic sequence of steps used in scientific research. Research process includes identify the problem, what is the problem, and then after that conducting a detailed literature review and collect data and finally analysis. Research process improves the reliability and validity of research. Research process will help the researchers to solve the problem in an organized manner. Research questions define the objectives and it will give the direction of research. Good research questions should be clear and measurable. They guide data collection and analysis methods. For example, how does automation improve manufacturing productivity? Research design means that is the overall framework used to conduct research. It includes sampling, data collection, and analysis methods. Proper research design improves accuracy and reliability. This uh, includes experimental design, survey design, case studies. Quantitative and qualitative approach means quantitative means dealing with numerical data and statistical analysis. Qualitative approach focuses on opinions, experiences, and observations. Quantitative methods includes surveys and experiments, whereas qualitative includes interviews and case studies. Theoretical models, building theoretical models and its validation. Theoretical models means that representing the real systems mathematically or conceptually. With the help of this mathematical model, we can explain scientific and engineering problems. Validation means checks whether, so now we have theoretical model. We have to validate whether this model matches the real world situations. So simulation represents a theoretical model, experiment represents the validation. If you have simulation and results, you have to conduct an experiment and validate this result, validate the theoretical result after conducting the experiment. Exploratory versus confirmatory research means exploratory means this is like exploring new ideas or problems. Confirmatory research means testing existing theories and hypotheses. Exploratory is flexible and open-ended, but confirmatory is very structured and using statistical methods. Experimental versus theoretical research. This involves experimental involves some practical experiments and observations. Theoretical mainly focuses on theories, concepts, equations, and models only. Experimental results will give some practical evidence. Theoretical research improves conceptual understanding. What is the role of reasoning in research? So reasoning helps researchers to analyze information logically. We have two categories, deductive reasoning and inductive reasoning. Deductive reasoning moves from general principles to specific conclusions, whereas inductive reasoning develops general conclusions from observations. So proper reasoning improves research validity and reliability. Next is literature survey and research sources. Literature survey means the researcher will study previous studies, previous journal articles, journal papers, books, study all those things related to the research is what is called a literature survey. This will help the researcher to understand the problem or the topic in detail. And also the researcher will be able to understand what are the limitations, what were the limitations of the previous research, and the researcher will be able to identify the gap, research gap. A proper literature review, a proper literature survey will helps the researcher to move the research in a proper direction. And also the another important point is that it helps the researcher to avoid duplicate research. If the researcher is not conducting a proper literature survey, he will be duplicating the research. So that's why the role of literature survey is very important. This is the basic basic concept of to start the research. For example, a researcher is planning to conduct research in digital twins in smart manufacturing. He should conduct a detailed study from IEEE, Springer, Science Direct, etc. First of all, the researcher should identify the topic, research topic. Then after that, he should select which database, journals, books, or conference papers he should choose it. So he will get proper time and he will get relevant informations quickly. So during the search strategy, he can use keywords, filters, publication year, author's name, etc. For example, artificial intelligence in healthcare, PubMed, Scopus, Google Scholar. So using those databases, and we can conduct the literature source. Identifying keywords and key concepts and keywords. Keywords means these are the words associated with the research, and key concepts means these are the main ideas related to the research. If we use proper keywords, we will get relevant research papers quickly. Researches, synonyms, technical terms, abbreviations, we can use this as keywords. For example, if the research topic is robotics in manufacturing, the possible keywords will be robotics, automation, smart manufacturing, industrial robots, industry 4.0. Locating relevant literature is another main process. The literature sources will be journals, books, conference proceedings, theses, reports, etc. Researchers, online databases, digital libraries, university repositories, using these to identify the literature. Choosing the relevant literature will improve the quality of the research. Commonly using research sources will be Google Scholar, IEEE Explore, Scopus, Springer, Science Direct, ResearchGate, etc. For example, machine learning research, we can select paper from IEEE Explore. Reliability of a source. We cannot blindly trust all the online sources. So all online sources are not reliable. So researchers should choose trusted and peer-reviewed sources. So reliable source means the expertise of the author, publisher reputation, peer review status, publication date, citations, and references. If the researcher is using reliable sources, that will increase the credibility and validity of the research. For example, IEEE journal articles are considered as the reliable sources, but if we use an unknown blogs, these are not reliable sources. So we can use IEEE journal articles. So this will be considered as reliable sources. Coming to experimental research and data analysis. Problem formulation. This is the main step involved in the research. The researcher should identify a problem, define a problem clearly. The problem should be clear. Then modeling and simulation means representing the real systems mathematically or computer models and then studying the performance of those systems is what is called modeling and simulation. In engineering research, this is very important. Experimental research means by controlling the variables, uh, identifying, understanding the relationship between the uh, cause and effect. The cause and effect relationship is what is called experimental research. For example, if changing the temperature, how this will affect the performance of the machine. So in experimental research, by manipulating the variables, study the cause and effect relationships. Cause and effect relationship, again, I have already mentioned that if one variable is changing, how the change in one variable affect the performance of the other. So if cause is an independent variable, then the effect will be dependent variable. Cause will be independent variable and the effect will be dependent variable. Hypothesis means this is a testable prediction. For example, automation increases production efficiency. Doing experiments, we have to check whether this prediction is correct or not. So this is a testable prediction. So the prediction is automation increases production efficiency. After conducting the experiment, we will be checking, okay, whether this statement is correct or not. Automation increases production efficiency. So this is the hypothesis is a testable prediction. After conducting the experiment, we have to check whether this testable prediction is correct or not. Measurement systems analysis, MSA. We have to check the accuracy, precision, repeatability, and reliability of the measuring system. So in quality control, this is very important. If the accuracy, precision, repeatability, and reliability of the measuring system is correct, then the result from that system will be correct. So in quality control, this is very, very important. Error propagation. Error propagation means how the error will affect the final result. Even though there is a small measurement error that will directly affect the result. Okay, there will be a big change in the final result. So this is that is the meaning of error propagation. How the error will affect the final result. So even though the error is very small, but how it will affect the final result. In some cases, even though the error is very small, it will create a big impact in the final result. Validity of experiments means whether the result is correct or not. We have to check whether for example, if we have simulation results, how we can validate those simulation results. So we can compare simulation results with experimental results. So validity of experiments is very important. Statistical design of experiments means design of experiment means how many experiments are required to get maximum information with the help of statistical methods. Planning design of experiments with the help of statistical methods called a statistical design of experiments. That means how many minimum experiments required to get useful information. Field experiments means out of the laboratory. Experiments conducted in real situations out of the laboratory. This will understand the real behavior of the system. Data and variable classification. How to collect data. So there are different methods to collect data such as surveys, interviews, observations, experiments, etc. Sampling means we have a big population from the big population, we have to select a small representative sample. That sample will represent the big population. So different examples will be random sampling, stratified sampling, systematic sampling, etc. These are examples of sampling. Observations and surveys. Observation means the researcher will directly directly observe the behavior or directly see the event, and then after observation he will be seeing all those things and recording all those things is what is called observation. And in surveys, the researcher will give some questions, or he will be asking questions in interviews. Through that, he will be collecting data. That is what is called observation and surveys. Numerical and graphical data analysis. Numerical analysis means calculations, using calculations, and the graphical analysis means, again, it is related with the charts, graphs, tables, etc., so that we can easily understand the data. So data we can analyze numerically as well as graphically, right? Numerically means analyzing the data by utilizing some calculations. Graphical means with the help of charts, tables, etc., analyzing the data. Inferential statistics means using sample data, generating conclusions about the population is what is called inferential statistics. Hypothesis testing, confidence interval, regression analysis, these are included in this inferential statistics. So inferential statistics means it is the generation of conclusions with the help of sample data. Generating conclusion about the population with the help of sample data is what is called a inferential statistics. So sampling technique, what is sampling technique? Sampling technique means we have a large population. From the large population, we will be taking a small sample, representative sample, and conducting experiments on those samples, and we will be predicting the result to the entire population is what is called a sampling technique. So choosing the sample is very important. So we have a big population. From the big population, we will be taking a sample, representative sample, and then by conducting experiments on that sample, we will be predicting the behavior uh, of the big population. That is what is called a sampling technique. Inferential statistics means we have the sample data, and with the help of this sample data, we will be generating conclusions about the population. This is called inferential statistics. Interpretation of results means uh, after conducting the research, the findings, explanation of the findings. That is what is called the interpretation of results. So initially we have our research objectives. So now we got the result, right? Okay. So this result is matching with the objective or not. That is what is called an interpretation, and also testing the hypothesis. R software for statistical analysis. The R is a software that is used used in statistical analysis and for data visualization. By utilizing this R software, we can generate the graph, hypothesis testing, regression analysis, data cleaning, etc. So philosophy means basic questions. This is a branch of science asking questions about life, knowledge, reality, truth. That is called a philosophy. For example, uh, what is the basis of human life? What is the truth? So finding answers to those questions is what is called a philosophy. So philosophy will improve the critical thinking, logical reasoning, and the problem solving ability of human beings. Science, technology, education, politics, religion, everywhere the use of philosophy is in a good way. For example, how artificial intelligence will affect the life of human beings. So suppose one researcher is asking how artificial intelligence will affect the life of human beings. Nature and scope of philosophy. The nature of philosophy is based on logical thinking, reasoning, and analysis. So philosophy will check the thinking of humans, beliefs, etc. The scope of philosophy is very broad. This will include science, ethics, education, religion, politics, art, society, etc. For example, medical ethics, engineering ethics, environmental philosophy. These are different applications of philosophy. The different branches of philosophy is will be metaphysics, epistemology, ethics, logic, and aesthetics. Metaphysics means this is to study the reality and the existence. Epistemology related with the knowledge and belief. Ethics means which one is right, which one is wrong. Study about which one is right, which one is wrong. Logic means reasoning and arguments. Aesthetics study the beauty and art. So these are the branches of philosophy. Metaphysics will study the reality and existence. Epistemology will study the knowledge and belief. Ethics is dealing with which one is right, which one is wrong, and logic means reasoning and arguments. Aesthetics represents the beauty and art. Ethics and moral philosophy. Ethics is dealing with which one is right, which one is wrong. Moral philosophy means uh, what is the expectation uh, of the people, what is the behavior of people we are expecting. This is what is called a moral philosophy. So ethics, honesty, fairness, responsibility. Ethics will promote honesty, fairness, and responsibility because ethics is dealing with the right and wrong uh, behavior, right? The study of which one is right, which one is wrong. So, for example, if in the case of research, if the researcher is writing a paper and he's adding a work of other person without giving proper citation, okay, to give proper citation is an example of ethical practice. If he is not giving proper citation, it is considered as an unethical practice. So this is an example related with the research. In research, there are so many scientific misconduct such as fabrication, falsification, plagiarism, etc. So this research ethics will helps the researchers to avoid those scientific misconduct. Nature of moral judgments. That means, for example, if one activity is right or not, deciding if one activity is right or not. This will related with the society, religion, culture, and values. For example, helping poor people is considered as morally good. Stealing is considered morally wrong, right? So deciding which, for example, deciding one activity is right or not. Scientific conduct and research ethics. In in conducting the research, the researcher should follow ethical behavior. That means honesty, transparency, and integrity. In order to avoid plagiarism, data manipulation, fabrication, and falsification, this this will help the researchers to avoid those problems, those scientific misconduct. Ethical research will increase the credibility of the scientific research. For example, researchers should report accurate experimental results without changing the data. Don't change the data. Researcher should report the accurate experimental data. Intellectual honesty and research integrity. Intellectual honesty means proper credit will be given to others' ideas and works called intellectual honesty. And research integrity means this is the truthfulness and reliability in the researches. False reporting and plagiarism, researchers should avoid. Honest research improves trust in science. For example, intellectual honesty. One example of intellectual honesty will be using references and citations correctly in a thesis. That shows intellectual honesty. Scientific misconduct. These are unethical practices. These are the violation. These are the unethical practices. This will reduce the reliability and public trust in scientific research. Falsification means changing the result or changing the research data. That is what is called a falsification. For example, changing the experimental results and showing the graph, showing the false improvement in the graph by changing the experiment, by changing the data and showing the false improvement in the graph is an example of falsification. Fabrication means creating artificial data. That means that data is not available. And then based on that data, that artificial data, result will be presenting. This is called a fabrication. For example, without conducting experiment, writing fake readings. This is an example of fabrication because there is no experiment conducted. Without conducting experiments, writing fake readings. This is an example of fabrication. Plagiarism means copying others' work without giving proper credit, called a plagiarism. For example, if you copy something from the internet and you are not giving proper citation in the thesis, this is an example of plagiarism. Duplicate publication means publishing the same paper in multiple journals. That means the paper is same and the paper is, for example, you have a same paper and the same paper is publishing in 2 different journals. So this is called a duplicate publication. Overlapping publication means taking a majority of the part from the previous paper already published and using that majority of the part publish another paper. That means slightly modify the old research results and publishing a new paper is what is called overlapping publications. Salami slicing means you have a big research and splitting the big research into smaller sections, and based on that smaller sections, publishing a result called a salami slicing. So you have one experiment, okay, and you have one experiment. You will be splitting this one experiment into 3 sections and publishing 3 papers is called a salami slicing. The problem is that the reader will not get a proper understanding about that big research. Selective reporting means avoiding negative results. For example, you will be conducting an experiment in a particular medicine. Okay. So in the case of medicine, we have positive results and the negative results. But when you publish, you will be publishing only the positive results. This is an example of selective reporting. When you publish it, you have to mention its positive results and its negative results. Then misrepresentation of data. Misrepresentation of data means you have the data and you will be representing the data in a different way. That means you will be misleading the data. For example, one best example is you have a graph, okay, and if you change the graph scale, and when you change the graph scale, say you can see some improvements largely in the graph. So by changing the graph scale and presenting the result as a positive result, that means you will be misrepresenting the data by changing the graph scale. That is what is called a misrepresentation of data. These are some of the examples of scientific misconduct. So publication ethics means publishing the research by following the ethical standards, ethical principles and standards. This will ensure the scientific integrity, transparency and honesty. So the research quality will improve, and in the scientific community, this will ensure the trust, right? So the importance of publication ethics and importance will be publication ethics ensures that research papers are published honestly and responsibly. Why this is required? Because we have to prevent that scientific misconduct explained earlier, previously, right? Like plagiarism, fabrication, falsification, duplicate publication, overlapping publication, salami slicing, misrepresentation of data, etc. So we have to follow some ethical standards to avoid these scientific misconduct. This ethical publishing improves the credibility and reliability of the scientific research. For example, giving proper citation to journal articles used in a thesis in an ethical publication practice. What are the best practices and standards? Best practices and standards means these are the accepted guidelines followed in research and publication. That means how to collect data properly, accurate reporting, peer review process, proper referencing and citation. So if you follow standards, then it will improve the quality of the research and transparency. Follow standards and improves research quality and transparency. For example, using APA or IEEE citation style correctly, that is considered as a best practice. What do you mean by conflicts of interest? So conflict of interest occurs when personal or financial interest will influence the research outcome. So researchers must disclose conflicts honestly. If there is a conflict, the researchers must disclose the conflict honestly. It occurs when personal or financial interest that will affect the research outcome. it is what is called a conflict of interest. So hidden conflicts that reduces the research credibility. For example, one of the best example I can say, a researcher is doing a particular research and it is funded by a pharmaceutical company, and this company is funding this researcher. Okay, and the researcher, when the researcher is publishing its outcome, he will be reporting results favorable to that company. Okay, so this will be a biased result, right? So he will be, when the researcher is publishing, the result after conducting this research, he will be presenting his data favorable to that company, pharmaceutical company. This is not the right way, because of the financial interest, he will not be presenting all the informations. So this is what is called a conflict of interest. Publication misconduct or scientific misconduct, I have already explained. These are the unethical practices in research publication, such as plagiarism, fabrication, falsification, duplicate publication, overlapping publication, salami slicing, misrepresentation of data, selective reporting. These are the publication misconduct that will damage the scientific reputation. For example, same research paper. Okay, you have a research, and you will be publishing the same research paper in two different journals. This is what is called a duplicate publishing. This is what is called a duplicate publication. This is an example of scientific misconduct or publication misconduct. When ethical rules are ignored, violation of publication ethics occurs, right? So the examples of violation will be improper citation, fake data reporting, fake authorship. Violation will reduce the scientific trust and research quality. For example, copying content from the internet without giving a reference is a publication ethics violation. Authorship and contributorship. Authorship and contributorship. So authorship means refers to giving credit to individuals who contributed significantly to research. Contributorship identifies additional contributors who supported your research. So this is the difference between authorship and contributorship. Those who are significantly contributed to the research, you have to given as authorship. Contributorship means additional contributors who supported your research. The thing is that only genuine contributors should be listed as authors. For example, a person who performed data analysis and manuscript writing deserves authorship. Complaints and appeals. During the publication, there will be some publication ethics issues. So researchers can report plagiarism, data manipulation, authorship disputes. So journal will investigate those issues and take appropriate action. So complaints and appeals are the procedures used to address publication ethics issues. For example, if a journal detects plagiarism in a paper, what will be the outcome? The outcome will be the paper may be rejected or retracted. So we will continue this after 10 minutes. So let's start the topic again. Research process. First of all, what is a research process? This is a systematic sequence of steps followed to conduct scientific research. What are the different steps involved in a research process? First of all, we have to identify what is the problem. Identification of research problem. Once you identify the research problem, then next step is to conduct a detailed literature review. Then based on the literature review, you have to form formulation of objectives and questions. Then testable statement will develop, hypothesis develop. Then how to conduct the research, that is what is called a research design. Then based on the research design, the researcher should collect data properly. Once he got the data through experiments, surveys, or case studies, or whatever it may be, once he collected the data, analyze the data properly with the help of, we have different softwares for analysis. For example, R software. Then finally, interpretation and conclusion. And the last stage will be preparing the report. This is the research process. This is what is called a research process. For examples, we can say studying automation in industries. For example, investigating the student performance, analyzing robot efficiency, research on renewable energy, or smart manufacturing analysis. Research questions means these are some specific questions that research aims to answer. Once the research will be completed, you will get the answer to this question. So the research starts with some specific questions called research questions that research aims to answer. For example, how does AI improve manufacturing? Does online learning affect the performance? Can robotics reduce labor cost? What causes machine failure? How does temperature affect metal expansion? Research design means this is the overall framework used for conducting research. In order to conduct research, you have to design it. Okay, for example, if you are planning to construct a building, you have to design it, right? If you are planning to manufacture a new machine, you have to design it. That means that will give you the overall framework. Same way, research design means this is the overall framework that is used for conducting research. There are different types of research design, such as experimental design, survey design, case study design, descriptive design, etc. For example, survey on online education, experiment on machine vision, case study on Toyota production system, quality inspection study, healthcare management analysis, etc. So what is the difference between quantitative and qualitative approach? So quantitative means that is dealing with quantity. Quantity means that is dealing with numerical data. Qualitative approach means that will be dealing with the experiences and opinions. For example, quantitative examples will be statistical analysis of marks scored by, say, 50 number of students, production output measurement, temperature measurement, because all these are dealing with numerical data. All these are dealing with the numbers. Then productivity analysis, machine speed analysis. So these are some examples of quantitative analysis. That means that is dealing with numbers or numerical data. Qualitative examples means student interview, worker observation, customer opinion surveys, social behavior analysis, case study discussions, etc. So these are examples of qualitative research. Then theoretical models, building and validating theoretical models. What is the difference between theoretical models and actual representation, right? So theoretical model means these are the mathematical representations of the actual system or conceptual representation of the actual system. For example, you can think about a robot simulation model. This is an example of a theoretical model. Fluid flow equation, because this represents this is the mathematical representation of the actual system. Economic prediction model, supply chain simulation, digital twin model is, again, this is an example of theoretical model because this represents the mathematical representation of the actual system. Exploratory versus confirmatory research means exploratory means, from the name itself, exploring new ideas or researching new ideas called exploratory research. Confirmatory research means we have to test, we have existing theories, we have to test whether that existing theory is correct or not. That is what is called a confirmatory research. That means you will be confirming that the existing theory is correct. Okay. Exploratory means you will be exploring new ideas, new problems, new solutions. So that is the basic difference between exploratory versus confirmatory research. For example, exploring AI applications, testing automation efficiency, studying customer behavior, confirming machine reliability theory, verifying medical treatment results. What is the difference between experimental and theoretical research? Experimental research means that is dealing with some practical experiments. So theoretical research means that is dealing with concepts and equations only. For example, laboratory testing of materials, machine performance experiments, mathematical fluid analysis, robotics simulation study. So robotics simulation study means that is dealing with the theoretical part, right? Heat transfer equations, again, that is related with the theoretical research. For example, laboratory testing of materials, that is an example of experimental research. Machine performance experiments. What is the role of reasoning in research? Reasoning helps researchers to analyze and so the researcher got the information, right? Data, right? So he should analyze and interpret those information logically. For that, the researcher needs a reasoning ability. So reasoning ability is required. Reasoning ability is required to analyze and interpret information clearly. There are two types of reasoning: deductive reasoning and inductive reasoning. So deductive reasoning means from a general conclusion reaches to a specific conclusion. That is called a deductive reasoning. The opposite is what is called inductive reasoning. From specific observation reaching to a general conclusion. For example, all metals expand when heated. Iron is a metal, therefore iron expands. Observing machine failure patterns, drawing conclusions from experiments. Coming to the literature survey and research process. What is the importance of literature survey? Literature survey means this reviews the previous studies related to a particular topic. For example, digital twin, okay, or robotics or automation. So this literature survey will help the researcher to understand the previous studies after conducting the literature review. That means previous studies. This reviews previous studies related to a particular topic. For example, studying previous robotic papers, reviewing AI journals, analyzing Industry 4.0 reports, reading conference papers, reviewing manufacturing case studies, etc. Planning a literature search identifies suitable. We have to identify suitable research sources. For that, we have to plan accordingly. So planning a literature search identifies suitable research sources. For example, searching IEEE database using Google Scholar, then Scopus journals, Springer resources, collecting conference articles. So plan properly so that we can identify suitable research sources. Then key concepts and keywords. Keywords are really important terms associated with a particular research topic. For example, artificial intelligence, digital twin, smart manufacturing, robotics, Industry 4.0. So these are examples of keywords. Then locating relevant literature. So relevant literature that includes journals, books, reports, and useful for research purpose. For example, IEEE Explore journals, Science Direct journals, Springer publications, Google Scholar papers, university theses, etc. Okay, so once we got some papers, we have to check whether the paper is reliable or not. The reliability of a source is very important. That means accurate. So we need accurate and trustworthy information, right, from the paper. So the reliability of a source is very important. For examples, we can use government reports, we can use university publications, scientific databases, international conference papers, peer-reviewed journals, etc. We can use experimental research and data analysis. Experimental research. In experimental research, we have to find what is the relationship between cause and effect. Cause and effect relationship using controlled experiments. Inside the lab, we have to conduct controlled experiments and identifying the cause and effect relationships between variables. This is what is called experimental research. For example, we testing the machine efficiency or measuring heat transfer, then material strength testing, robot motion analysis, production line experiments, etc. Cause and effect relationship. That means how, so if we have two variables, if I am changing one variable, how it will affect the another. For example, if we have an independent variable and we have a dependent variable, if I will change the independent variable, how it will affect the dependent variable. So cause means independent variable, effect represents the dependent variable. So we have to study the cause and relationship between variables. For example, heat causes metal expansion, right? Speed affects machine output, right? So automation improves productivity, right? Pressure changes fluid flow. Training improves worker performance. So we have to study if one variable is changing, how it will affect the other. This is what is called a cause and effect relationship. Hypothesis. What do you mean by hypothesis? Hypothesis is a testable prediction in research. Okay, so we can test that prediction. After completing the research, we have to tell whether this statement is right or wrong. So a testable prediction in research is what is called a hypothesis. We have to develop it. For example, automation increases efficiency. After completing the research, we will test this hypothesis, right? Automation increases efficiency. After completing the experiment, we have to tell, okay, automation increases efficiency or not. AI reduces human error. Smart sensors improve quality. Temperature affects strength. Robotics reduces labor cost, etc. MSA. MSA means measurement system analysis. This means this is very useful in quality. So this analysis, measurement system analysis, will evaluate the accuracy and the reliability of the measurement systems. For example, calibration of systems, testing, measurement repeatability, accuracy checking, quality inspection analysis, machine sensor validation, etc. Error propagation. Error propagation means how measurement error will affect the results. This is what is called error propagation. If the measurement is an error one, how it will affect the result, how the error will propagate from the measurement to the final result. That is what is called error propagation. For example, temperature measurement error, sensor reading variations, machine calibration error, statistical calculation error, laboratory instrument inaccuracies. Validity of experiments. We have to check, okay, now, for example, after completing the experiment, we got some values, right, from the experiment. We have to check whether this result are accurate and reliable. This is called a validity of experiments. We have to, how you will check the validity of the experiments. We have to repeat okay, we can do one thing, we can repeat the experiment and check that we will be getting the same result again and again. Or another one is called, we can compare this value with standard values, or calibration testing. Statistically, we can verify the result. Independent validation. So we have to validate it. Once we will got the result, we have to validate it. Statistical design of experiments means we have to plan experiments efficiently, right? Before conducting the experiment, we have to plan the design of experiments. How many experiments are required? So we will be using statistical tools to design the experiments. That is called a statistical design of experiments. Factorial design, ANOVA analysis, regression analysis, response surface methodology, quality optimization studies, etc. These are the examples of statistical design of experiments. Field experiments represents, so experiments actually we will be conduct inside the laboratory, right? But we have to conduct these experiments in real world situation, real world environments. That is what is called a field experiments. So for example, traffic flow study, agriculture field testing, smart city analysis, industrial production monitoring, environmental testing. So these are examples of field experiments. So data analysis topic, data and variable. So data and variable classification organizes data into categories. So we have data, right? So organize the data into categories for analysis. Before analysis, we have data and variables. We have to classify the data and variables in and organizes this data into different categories so that we can analyze it properly. That is what is called data and variable classification. For example, I have already mentioned we have qualitative data, we have quantitative data. We have to organize the data into categories so that we can analyze those data properly. Continuous variable identification, discrete variable analysis, categorizing survey responses, etc. So data and variable classification means we have to organize the data into different categories so that we can analyze the data properly. Different methods to how we will collect data. Different methods to collect data will be, for example, experiments. Okay, so do an experiment, and after conducting the experiment, we can collect the data. Observations, by observations we can collect data. Surveys, interviews, questionnaires. So there are different methods and used to gather research information. So we need, in order to conduct a research, we need information, right? So to collect the information, we can conduct different data collection methods such as surveys, interviews, observations, experiments, questionnaires, etc. Sampling means you have a large population, right? So from this large population, we have to select a subset from this large population. This small sample represents this entire population. This sampling is very important. This is what is called a sampling technique. So we have to conduct an experiment on this sample. So the result from this sample, that will represent the result of the entire population. So this sample selection is very important, because if we choose a wrong sample, the result will be a wrong result, and it represents a wrong result that represents the entire population. So we have to choose this sample properly, because this sample represents the subset of this entire population, right? So there are different examples such as random sampling, stratified sampling, systematic sampling, cluster sampling, convenient sampling, etc. Observation and surveys. These observation and surveys, again, these are different methods for collecting research data. For example, classroom observation, employee performance survey, customer satisfaction survey, industrial safety observation, online questionnaires. These are examples of observation and surveys. Numerical and graphical data analysis. So numerical and graphical data analysis uses numbers, charts, and graphs for interpretation. For example, bar chart analysis, right? Then pie chart representation, histogram plotting, statistical calculations, scatter plot analysis. So the data will be analyzing numerically. For example, statistical calculations, or graphically. Graphically means with the help of different charts such as bar chart, pie chart, histogram, scatter plot analysis, etc. Analyzing the data numerically using different calculations, or analyzing the data with the help of graphs such as bar chart, pie chart, histogram, scatter plot analysis is what is called a numerical and graphical data analysis. Inferential statistics means, I have mentioned sampling technique, right? Or sampling, I have mentioned. Sampling means choosing a subset that represents the entire population, right? So using this sample data, we will develop conclusions about the entire population. This is what is called a inferential statistics. That means using the sample data, we can draw conclusions about the entire population is what is called a inferential statistics. Hypothesis testing, regression analysis, correlation studies, confidence interval analysis, ANOVA testing, examples. So these are examples of inferential statistics. And finally, we have to interpret our result. That means we have to explain what is the meaning of research findings. That is what is called interpretation of results. Explains the meaning of research findings. For example, if we have some statistical outputs, we have to explain it. Then if we have some experimental results, we have to compare it. That means we will be interpreting our findings. Then research conclusions, drawing research conclusions, then research trends, identify research trends, and also verifying the hypothesis. R software is a tool that is used for statistical analysis and data visualization. For example, if we want to plot a graph, we can use R software to plot the graph. Regression analysis in R, then hypothesis testing using R, data visualization, statistical calculations using R. So R software is a wonderful software to do all those things, such as statistical analysis and data visualization. Then coming to philosophy, ethics, and the scientific misconduct. Philosophy that will study knowledge, truth, life, reality, ethics, etc. For example, ethics in AI, moral values in society, truth in scientific research, logical thinking analysis, human behavior study, etc. So, what is the difference between ethics and moral philosophy? Ethics studies which one is right, which one is wrong, right? So studying the right or wrong behavior is what is called ethics. That is called ethics. For example, in research, avoiding plagiarism. So we should understand which one is right, which one is wrong, right? Avoiding plagiarism. Okay, honestly reporting the findings, respecting the participants. You should follow fair research practices, proper citation. So which one is right, which one is wrong? So this is understanding those is what is called ethics. So ethics studies right and wrong behavior in research. Scientific misconduct means these represents what are the unethical research practices. Examples: the unethical research practices such as plagiarism, fabrication, falsification, duplicate publication, selective reporting, salami slicing, overlapping publication, misrepresentation of data. These are some of the examples of scientific misconduct or publication misconduct. Publication ethics. So ethics we have already mentioned. Ethics means which one is right, which one is wrong, right? So ethics studies the right and wrong behavior, right? So publication ethics means during the publication of the research, the researcher should make sure that the ensures honest and responsible publication of research. For example, proper referencing is required. Data reporting must be accurate. Ethical approval, transparent publication, honest authorship. So once again, we will repeat this topic again. First of all, starting with the research process. So first of all, what is the research process? Process means process represents process involve different steps, right? In order to conduct a particular research, for example, digital twin in manufacturing. So we have to follow different steps, starting from the beginning to end, to get a better result. To conduct a scientific research properly, we have to follow some steps. We have to follow sequence of steps. This is what is called a research process. So research process means this is a systematic sequence of steps followed to conduct research. What are the steps involved in research? So basically, we have 9 different steps involved in a research process. So starting from the problem identification. What is the problem? Okay, before starting the research, what is your problem? And finally, the result will be report preparation. You have to present your findings in your report. So starting from the problem, and you have to present your solution in your report. So starting will be the problem identification, and the final step will be the report preparation. That means publishing. Okay, so after identifying the problem, you have to conduct a detailed literature review, and then based on that, you have to form objectives and research questions. Then you have to develop hypothesis, and you have to design your research, and after that collect data properly based on the research design, analyzing the data with the help of different tools, and finally interpretation and conclusion, and the last stage will be report preparation. So these are the 9 steps involved in the research, starting from the problem identification. After that, conducting a detailed literature review, then formulation of objectives and questions, hypothesis development, then research design selection. Based on the research design selection, collect data properly, and then after that, analyzing those data with the help of any tools, and then finally analyzing the data. The next step will be interpretation and conclusion after analyzing the data, and then based on that, you have to prepare the report. So these are the steps involved in this research process. For example, studying automation in industries. For example, studying automation in industries, or investigating student performance, analyzing robot efficiency, research on renewable energy, smart manufacturing analysis, etc. So research questions. First of all, I have already mentioned what are the steps involved in research process. First of all, you have to identify what is your problem, then conduct a literature review, and then after that, you have to frame research questions, the objectives. So research questions means these are some specific questions that research aims to answer. You have to form some specific questions, and you will get solution to those questions at the end of your research. So your aim, your main focus is to find what is the solution to those questions. These specific questions are called research questions. For example, how does AI improve manufacturing? Does online learning affect performance? Can robotics reduce labor cost? What causes machine failure? How does temperature affect metal expansion? Then you have to design your research properly. So that design means the overall framework used for conducting the research. We have different types of research design, such as experimental design, then survey design, case study design, descriptive design, etc. For example, survey on online education, experiment on machine vibration, case study on Toyota production system, quality inspection study, healthcare management analysis, etc. So research design means that represents the overall framework used for conducting the research. What is the difference between quantitative and qualitative research? Quantitative means dealing with new numbers, dealing with the numerical data, whereas qualitative research is dealing with experiences and opinions. For example, statistical analysis of marks scored by, say, 50 students. This is an example of quantitative research because that is dealing with numbers. production output measurement, temperature measurement. So temperature measurement, again, dealing with the temperature, numbers, numerical data. Again, this is an example of quantitative approach. Productivity analysis, machine speed analysis. Qualitative analysis means that is dealing with experiences and opinions, studies the experiences and opinions. For example, worker observations, customer opinion surveys, social behavior analysis, case study discussions, student interviews. Then the importance of building and validating theoretical models. Theoretical model means it is the mathematical representation or the conceptual representation of the actual system. So, for example, I can say I have a robot simulation model that actually represents the actual robotic system, right? So, fluid flow equation, economic prediction model, supply chain simulation, digital twin model, etc. So, these are examples of theoretical model. Theoretical model means these are conceptual or mathematical representations of the actual system. Best example is robot simulation model. The difference between exploratory and confirmatory research is exploratory research will explore new ideas. Confirmatory research means you have existing theories, you have existing ideas. We have to confirm, we have to do a research and make sure that the existing theory is correct or not. That is what is called confirmatory research. Exploratory means you will be exploring new ideas, new solutions, new problems. That is what is called exploratory research. For example, exploring what are the AI applications, exploring AI applications, testing automation efficiency, studying the customer behavior, confirming machine reliability theory, verifying medical treatment results, etc. Then experimental versus theoretical research. Experimental research, the difference between so I have mentioned what is the difference between exploratory and confirmatory. Exploratory means you will be exploring new ideas, new concepts, new theories, etc. Confirmatory research means you have existing theories, you have existing informations. So after completing the research, you will make sure that, okay, this theory is correct. Okay, you will be confirming it. That is the difference between exploratory and confirmatory research. Then another type of research is called experimental versus theoretical research. Experimental research means that will be using practical experiments. That means you will be working with actual machines, instruments, and you will be getting data after completing the experiments. This is what is called experimental research. Theoretical research means you will be using concepts, theories, equations only. There is no machines, there is no practical setups involved in theoretical research. For example, laboratory testing of materials. You will be testing materials inside the laboratory. That is an example of experimental research. Machine performance experiments, mathematical fluid analysis, robotics simulation studies, an example of theoretical research. Heat transfer equations, example of theoretical research. What is the importance of reasoning in research? So we have, once we got data or informations after completing the experiments or theoretical activities, we have to analyze it properly, right? We have to interpret those informations properly. So we need, the researcher needs reasoning ability to analyze and interpret informations logically. There are two types of reasoning: deductive reasoning and inductive reasoning. So deductive reasoning means you will be drawing conclusions from general statements. From the general statements, you will be generating some specific conclusions. For example, I can say all metals expand when heated. So this is a general statement, right? So iron is a metal. So I can say, therefore, iron expands. So we have a general statement. From the general statement, I draw a conclusion, a specific conclusion. This is called a deductive reasoning. Okay. So in order to interpret information logically, the researcher needs this ability, reasoning ability. Then coming to literature survey. Coming to literature survey and research sources. So what is the role of in research process? I have mentioned the first step is to identify a research problem, right? So once you have identified the research problem, The next step is to what you call conduct a detailed literature review. Literature review means review the previous studies related to a particular topic. The particular topic will be your research problem. What is your research problem? After identifying the research problem, you have to conduct a detailed study about that particular topic. This is what is called a literature review. For example, reviewing AI journals, studying previous robotics papers, analyzing Industry 4.0 reports, reading conference papers, reviewing manufacturing case studies, etc. Planning. To conduct a proper literature search or literature review, you have to plan properly, right? So that means you should use proper suitable research sources. For example, IEEE database, Google Scholar, Scopus journals, Springer resources, collect conference journal articles, etc. Keywords and key terms, key concepts and keywords. Identify keywords and key concepts are very important related to a research topic. For example, artificial intelligence, digital twin, smart manufacturing, robotics, Industry 4.0. That means the terms associated with your research is what is called a keywords. Locating relevant literature is another important area. Journals, you can refer journals, books, report useful for research. Examples, IEEE Explore journals, Science Direct articles, Springer publications, Google Scholar papers, university thesis, etc. The reliability of a source is very important because we need trustworthy information. We need accurate information. So make sure that the source you will be using is very reliable. For example, peer-reviewed journals, government reports, university publications, scientific databases, international conference papers, etc. Coming to the experimental research and data analysis. So experimental research means we have to conduct experiments inside a laboratory, and we have to identify the cause and effect relationship between variables. So you have independent variable and you have a dependent variable. So in a controlling environment inside a laboratory setup, you have to conduct experiments. You have to identify the cause and effect relationships between independent variable and dependent variable. This is what is called a experimental research. Testing machine efficiency, measuring heat transfer, material strength testing, robot motion analysis, production line experiments. Cause and effect relationship. So this you already know, right? You have two different variables. If one variable is changing, what will be the effect of the another variable? Cause and effect relationship. If one variable is changing, for example, heat, if temperature is changing, how it will affect the another variable? How speed will affect the machine output? How automation, if I am incorporating automation, how it will affect the productivity? If pressure is changing, how it will affect the fluid flow? If I am giving proper training to the workers, how it will improve the performance of the worker. So if one variable is changing, how it will affect the another variable. So we have to identify the cause and effect relationship between different variables. Hypothesis. This is very important in research. We have to prepare a testable statement. We have a prediction. Okay, so we will be predicting in our research. Beginning of the research, I am saying, okay, for example, automation increases efficiency. This is a statement. Okay, this is a prediction. Okay, this is a prediction in research. So after completing the research, I have to check. I have to say, okay, whether this statement is correct or not. Okay, for example, artificial intelligence reduces human error. So again, this is a prediction. This is a testable prediction. That testable prediction is what is called a hypothesis. For example, smart sensors improve quality, or temperature affects strength, or robotics reduces labor cost, etc. MSA means measurement systems analysis. So in experimental research, you will be conducting different experiments, right? And after conducting the experiments, you will be getting different values, different data from those experiments. How you will make sure that that data you will be getting from the experiments is correct or not? How you will make sure that the data you will be getting from the experiment will be correct or not? Okay, so you have to analyze your measurement systems properly. Calibration of instruments required. Okay, and another one is called you have to repeat the experiments again and again, and if you will be getting the same value again and again, and you can confirm that okay, you will be getting correct value, accurate value. Measurement repeatability, testing measurement repeatability, accuracy checking, quality inspection analysis, machine sensor validation, etc. Error propagation studies how this, okay, for example, after completing the experiment, you will be having some values, right? Okay, and in that measurement, okay, just imagine your value becomes is a value having some error. Okay, of course this will directly affect your final result, final output, right? So that means your error will propagate from here to the final result, right? So this is what is called a error propagation. That means the measurement error, how the measurement error will affect the final result. Okay, the area to study how the measurement error will affect the final result is what is called error propagation. For example, temperature measurement error, sensor reading variations, machine calibration errors, statistical calculation errors, laboratory experiment inaccuracies, validity of experiments. Okay, after completing your experiment, okay, you got some results, right? How you will make sure that your results are accurate and reliable? We have to validate it. So validity means checking your results are accurate and reliable. One thing we can do, we can repeat the experiment. Okay, we can repeat the experiment. If you repeat the experiment, you will be getting the same value. Okay, so we can make sure that okay, this is accurate, this is reliable, because I have conducted this experiments 10 times, I'm getting the same result again and again. And another one is we can compare this value with standard values or calibration testing. Statistically we can verify the result, independent validation. So once we got some results, we have to validate it, whether the results we got are accurate and reliable. How many experiments do we need to conduct? How many experiments do we need to conduct to get a maximum amount of information? For that, we have design of experiments. We will be using some statistical techniques to design the number of experiments. How many experiments are required? You have to plan your experiments efficiently so that you will get maximum information by conducting minimum number of experiments. By conducting minimum number of experiments, you will get maximum amount of information. This is what is called design of experiments, utilizing statistical techniques. That is what is called a statistical design of experiments. We have factorial design, ANOVA analysis, regression analysis, response surface methodology, quality optimization studies, etc. So, in experimental research means you will be conducting experiments inside laboratory setting, right? If you will be conducting this experiments in real world situation, that is what is called a field experiments. Okay, so for example, agricultural field testing, smart city analysis, industrial production monitoring, environmental testing, etc. So experimental research means you will be conducting experiments inside the research and collecting data inside the lab, and you will be analyzing the data inside the lab. That is what is called experimental research, right? Field experiment means you will be conducting the same research in real world environments to get the real world behavior. Data analysis, data and variable classification. After completing the experiment, you will be getting the data, right? Okay, so the first step is to organize the data properly. You have qualitative data, you have quantitative data. So we have to categorize, or we have to organize this data and variables properly so that we can analyze those data properly. For example, quantitative data, qualitative data, continuous variable, discrete variable, categorizing survey responses, etc. So that is dealing with the data and variable classification. How you will collect data? Experiment I have already explained. So after completing the experiment, you will get the data, right? So this experiment is an example to collect data, right? So you can collect data through interviews, observations, surveys, questionnaires. So there are different methods. used to gather research information is what is called a data collection method. So experiment is one method. Then sampling technique. So this is very important in data collection and data analysis. You have a large population. From the large population, you have to select a subset that represents the entire population. Okay, and then conducting some work on that subset, so that you will get a result from that subset. That result represents the result of the entire population, right? So sampling technique means select a subset from a large population is what is called a sampling technique. There are different sampling techniques such as random sampling, stratified sampling, systematic sampling, cluster sampling, convenient sampling, etc. Observation and surveys. Okay. Again, observation and surveys. Again, these are data collection methods. We can collect data through observation or surveys. We can collect research data, not only experimental experiments. Through experiments, we can collect data, but we can collect data through observation, surveys, etc. For example, classroom observation, employee performance surveys, customer satisfaction surveys, industrial safety observation, online questionnaire, etc. Once you got the data, okay, you have to analyze the data, right? So you can analyze the data numerically as well as graphically. So what is the difference between numerical analysis and graphical data analysis? That means, for example, if you will be using some statistical calculations, this is what is called a numerical analysis. For example, you will be representing this data like a bar chart or a pie chart or a histogram or a scatter plot. This is what is called a graphical data analysis. So you can analyze the data either numerically or you can analyze the data graphically. Inferential statistics. I have already mentioned what is sampling technique. It is a subset of the entire population. With the help of this subset, with the help of this sample data, you will be able to draw conclusions about the entire population. This is what is called inferential statistics. Hypothesis testing, regression analysis, correlation studies, confidence interval analysis, ANOVA testing, etc. Interpretation of results means explaining the meaning of research findings. Once you got the findings, you have to explain it, right? So that is what is called interpretation. For example, if you have, I have already mentioned I have already mentioned a numerical analysis, data analysis, and a graphical data analysis. After analyzing the data numerically or graphically, you have to explain the meaning of your findings. For example, if you have some statistical outputs, you have to explain what is the meaning of this. Or if you have some experimental results, you can compare different experiments, right? So, or you can drawing some research conclusions, you can identify research trends, or you can verify hypotheses, etc. The software that is used to conduct statistical analysis is called R software. R software is used for statistical analysis and data visualization. For example, if you want to plot graph, you can plot in graph. You can conduct regression analysis in R. You can conduct hypothesis testing using R. You can conduct data visualization in R. You can conduct statistical calculations using R. Then coming to the next topic, philosophy, ethics, and the scientific misconduct. So philosophy means it is dealing with the knowledge, truth, reality, and ethics. The science that is dealing with ethics, knowledge, truth, reality is what is called a philosophy. For example, ethics in AI, moral values in society, truth in scientific research, logical thinking analysis, human behavior study, etc. Ethics and moral philosophy. Ethics means which one is right, which one is wrong. For example, in the case of research, which one is right? Okay, avoiding plagiarism. Okay, that is the right thing, right? Honest reporting. Okay, that is the right thing. Respecting participation. Respecting participants. Again, this is an example of right behavior, right? Fair. You should follow fair research practices. So which one is ethics? Research ethics means that is dealing with which one is the right and which one is the wrong behavior. Proper citation, that is the appropriate behavior, right? Scientific misconduct or publication misconduct, right? So unethical research practices is what is called a scientific misconduct. So scientific misconduct includes unethical research practices like plagiarism, falsification, fabrication, duplicate publication, overlapping publication, selective reporting, salami slicing, misrepresentation of data, etc. Publication ethics. So ethics, I have already mentioned which one is right, which one is wrong, right? In publication, again, we should follow the right behavior, right? Not the wrong behavior, right? So honest and responsible publication of research. When you publish a particular research, proper referencing is required. Data reporting must be accurate, ethical approval, transparent publication, honest authorship. So sampling, I am going to explain this sampling technique again. So sampling technique means you have a big population, okay? So from this big population, you will be taking a small sample, okay? Because it is very difficult to study the entire population, right? So because of that, to study the entire population, it will take too much time, right? Effort, then cost is too much, right? So in that situation, we will be taking a small group that representing the entire population is what is called a sampling technique. So we have a random sampling. So random sampling means in every member in this population will get an equal chance. Okay, so equal opportunity for all members. That is what is called a random sampling. This is a simple and unbiased method. Results are more reliable. For example, you can think about class attendance register. Okay, you have 50 students. You have 50 students in your class. Okay, by through lottery method, that means the name is written on a paper and put all these papers into a box and then take 10 students from the paper. Okay, so this is an example of random sampling using lottery method, selecting 10 students from the class attendance register. Or you can think about factory workers. You have the factory workers, say 100 workers in a factory. Okay, from the computer, randomly select 10 workers. This is again an example of random selection. Then to conduct a survey, randomly select, say, 10 mobile numbers. Election of, the election opinion poll, random votes. Okay, this is again an example of random sampling. Again, from hospital patients, take random samples. So the advantage of random sample is bias is very less. We can easily conduct, we will get reliable results. The problem is that if the population is very large, it is very difficult. So we need complete population list to, for example, I have already mentioned you have 50 students in the class registry. You have to return all the 50 students in 50 papers, and you have to put all these inside the box, and you will be taking 10 from this. So everybody will get an equal chance, right? So we need, the problem is that we need complete population list. That is one example. Another one is called a stratified sampling. So stratified sampling means, stratified means you have different strata. So strata means different layers, right? So that means we have different subgroups. Okay, and from these subgroups we will be taking the sample. So that means the population is divided into different categories, different layers. That is what is called that is why this is called a stratified sampling. That is what is called a stratified sampling. Stratified means you have different strata. Different strata means you have different layers. So the population is divided into, say, 5 different categories. Okay, and so for example, we have 5 different groups. Okay, so each group gets a representation. For example, okay, I will give you one example. of a stratified sampling. So for example, take the example of a classroom. So we have male students and we have female students. So divide the class into two stratas, two layers. One is male students, another one is female students, right? Then we will be selecting samples. This is an example of stratified sampling. Or you have you can think about an office having different departments, right? So we will be selecting different employees from different departments. Okay. Then urban and rural population, separating urban population and rural population. Then conducting the survey. Again, this is an example of stratified sampling. Then based on age groups. So we will be categorizing the data into different age groups. So we have different layers, different stratas. And another example is categorizing people with a different income groups. So these are examples of stratified sampling. The advantage will be better representation, more accurate results, and useful for heterogeneous population. But the disadvantage will be this is more time consuming than random sampling, and this is a complex process because you have to divide the entire population. You have to divide this into different layers, different stratas. So this is time consuming comparing with, and also this is a complex process comparing with the previous random sampling process. Next is called systematic sampling. So systematic sampling means fixed interval taking sample. Okay, so in every list we will be taking nth item. For example, let's take another example. Okay, you have say 50 students. Okay, and we will be selecting every fifth student. Okay, that means we have a fixed interval. That means I am selecting the fifth student. Okay, or in the case of factory, I am selecting every 10th product. Okay, I am checking the quality of the product and I am taking every 10th product. So there is a fixed interval. This is what is called a systematic sampling. Or in customer survey, I am taking every third customer. Or in library books, I'm checking every 20th book. This is an example of systematic sampling. I'm in traffic survey. I'm checking the every 15th vehicle. So this systematic sampling means we have a fixed interval. Okay, and then take the sample. This is what is called a systematic sampling. Stratified means you have different layers or different groups. From the groups, we will be taking the sample. Random sampling means we will be randomly selecting like a lottery. And for example, we have 50 students in the classroom, and write the name of the 50 students in 50 different papers and put inside a box and selecting say 10 students from the 50 students. This is what is called a random sampling. So systematic sampling means you have taken samples from fixed intervals. I'm selecting every fifth student, or I'm taking every 10th product from the factory, or I am selecting the third customer in the customer survey. I'm checking every 20th book in the library. I'm checking I'm tracking the every 15th vehicle in the traffic survey. This is again simple method, time saving, easy implementation. But the problem is that if there is a hidden pattern in this, we will be facing some bias, and also the population order will affect the result. Another one is called a cluster sampling. So cluster sampling, again, from the name it is very clear. We will be dividing into clusters, okay, or groups. Then we will be choosing some clusters only. Okay, this is used for large population studies. Entire clusters are selected. For example, you can think about schools clusters. Okay, so dividing, so in a cluster that contains different schools, right? Okay, so divide the school clusters, and from the school clusters we will be selecting some schools. Or you have different cities, and we will be selecting some cities. And also you have hospital branches. From this hospital branches, we will be selecting some branches. Select villages and conduct the survey. And factory units, take the selected units and study. This is very cost effective, suitable for large geographical areas and easy data collection. But the problem is accuracy is less and higher sampling error. Another one is called a convenient sampling. So convenient sampling means this is a non-probability sampling. Whoever is easily available, we will be taking those as samples. That is called a convenient sampling. The characteristics will be easy and quick method. So participants selected based on the availability. For example, I will be taking a nearby student to conduct a survey, okay, or I will be using my friend or colleagues to fill a questionnaire, okay. So social media users will conduct the survey, so collect immediate feedback from the classroom students. The advantage is that, so the advantage of convenient sampling is that it is a very easy method, low cost method. We can quickly collect the data because I'm interacting, I'm taking the data based on the availability only. So quickly I will get the data, but the problem is that high bias. The result may not represent population accurately and the reliability is low. Okay, so these are the different classifications of sampling techniques. Random sampling like lottery, and stratified means divided into different stratas or groups, and from the groups selecting the samples like male and female students in a classroom, selecting different employees from different departments, etc. Systematic sampling means we have different fixed intervals, right? So I'm selecting every fifth student. Okay, after selecting the fifth student, then next I'm selecting the 10th student. The next I'm selecting the 15th student. Then next I'm selecting the 20th student. And for example, in the case of factory, the product is coming, right? I am selecting every 10th product. So first I'm selecting the 10th product. Then next I'm selecting the 20th product. Then next I'm selecting the 30th product. So every 10th product I'm selecting. So this is like there is a fixed interval. This represents systematic sampling. Cluster means dividing the population into clusters, and then we will be selecting the sample called a cluster sampling. Convenient sampling means easily available. Take the sample from the availability. This is a non-probability sampling method. So the participants will be selected based on the availability. That is what is called a convenient sampling.